feel really excited to be interacting with them, sharing my experience with them on how to make data science and AI work for the businesses. Now, before I start with my presentation, what I wanted to share is why did this topic come to my mind and why is it very relevant in today's world? As we talk about new advancements which are happening in AI ML, we keep on talking about new NLP related techniques which are coming up, new reinforcement learning uh, techniques which are coming up. We talk about deep learning and everything. People are talking about computer visions and all. We all are so much excited to be building up the models to create a model which has a high sensitivity, high specificity, which has high accuracy. And we all are very excited on what machine could do using a data, leveraging the data and applying the intelligence over it. But still in an organization which are not digitally made. And what do I mean by not digitally made? Other organization which has continued to exist, say for 30 years, 40 years, 50 years. If I have to talk about Indian context, say we talk about utility companies, we talk about manufacturing companies like Tata's or say NTPCs, or we start talking about industries which are Infosys and everything. So there are some traditional companies which were not built over digital infrastructure, and which was compared to today's new age companies, just like FANG companies. They're built on a digital platform, on AI platform, where everything has been curated to support AI, which is unlike a traditional setup where your IT setup, your analytics were playing more of a supporting role rather than a role where it was in center of it. So the data is desperate. People are investing, but still they are not finding the value. And that's where they're undergoing some of the big digital transformation within the organization to leverage AI ML. I can tell like companies like Domino's, Burger King, which you would not imagine using a data science. They have slowly used data science. Companies like Vodafone, they have used data science. Companies which are as traditional as a microchip development companies, which are developing utility chips like Schneider Electric and everything, they have adopted AI/ML, which is pretty unique because if we talk about AI/ML, we traditionally deal with FANGs of the world, where we say, okay, the data is there, the experience is there, the engagement is there, and we want to know how we could embed analytics into it because your data is curated pretty well. So as there has been challenge in the traditional setup where AI and ML hasn't been the core of things, I thought like, let us discuss how to make AI work for the traditional businesses so that leaderships who are come and ask me, okay, we have invested close to 500 million in analytics. What is the value we are getting from it? I have setup of 500 people who are working analytics setup. What is the value which has been generated and has been realized? There are other set of people who say, hey, I have heard like analytics is doing wonders in other industry. How could analytics do wonder for me? There are people who have implemented analytics, and I'm talking about the FANGs of the world, but still they have faced certain challenges. I can talk an example of Amazon. Amazon embedded the analytics in hiring, where they was not manually screening the profile, but letting AI screen the profile. At the end of it, they faced an ethical dilemma where as their population was having more males, the resume was sort of getting deselected if it was for females, even if they had a similar credential. So because of the biased nature of the model, they had to be deselected. Same thing happened in terms of Apple Pay, where Apple Pay was trying to lend money to different users who were using their platform, and they were having a higher credit limit for males as compared to females. So people either don't realize the value of the AI, where even they have invested, say, 400 members team, 200 members team, or even like as small as 10 members team. They say, hey, I get a lot of great outputs, but I don't know what to do with that great output. I cannot implement it. It's a great knowledge to have, but what should I do with it? There are a lot of things which happen with that. The other leader who comes up totally confused and he says, okay, how do I become a part of the journey? And then there are people who deploy it successfully and then they face those ethical problems where they get a bad publicity or a bad press. So as I set up the background, like three problems which businesses are facing or traditional businesses are facing in terms of being left out, in terms of ROI, in terms of ethics in AI, how we will be taking an hour forward. So what we'll be doing is in this hour, we will start by discussing a bit of terminologies in AI and ML. And what I thought it is important because sometimes people come up and ask me, the new age AI has started coming up, which is something which you should be leveraging. And I'm like, AI is not new. There is something different which is driving AI. And we should understand what AI can do and cannot do. The second thing which we'll discuss is how the value is getting generated by analytics. And again, we will have both the perspective of a data science and a business. Third, before solving problem, we need to deep dive the problem, like what are the challenges associated with analytics. Again, there we will be talking about both the business side of the things and the technical side of the thing. And last is what is the framework which we should be following in order to achieve a successful use case and a successful deployments of AI solutions. Again, you will see me talking a lot about business sides and data science sides because what I believe is in order to have a successful deployment, you need to have people marry with the technology. You cannot have technology working alone. You cannot have people. So quick background, like what's the difference between AI and ML and deep learning as well? Because these are terminologies which a lot of people have heard and they keep and ask like, okay, should I be using AI, ML, and everything? So if you look at the chart at the left, it clearly says like deep learning is subset of ML and ML is subset or enabler of artificial intelligence. Artificial intelligence is nothing but a program which learns and reasons like humans. A very simple thing could be, hey, you press a button and the fan switches on. You press a keyboard button and it types a certain thing. That's what you want. And program has learned it. Like, okay, by pressing a button, what you should be doing. By pressing a button, you should open the gate. So that has existed for ages, not right now. Any technique which you will see that has existed for ages. Just go back and imagine old age electric fuse. They know like, hey, if your voltage goes or ampere goes above a threshold, you need to break. So that is something which existed from long time. So why do people have started talking about artificial intelligence all of a sudden when it existed so long? It has happened because of rapid investment in machine learning. And machine learning is sort of a thing which brings a lot of probabilistic and statistical element into artificial intelligence. Earlier, it was purely like 1 or 0 level which people are working, but right now people are working between 1 and 0. So they're working on probabilities and everything. Second thing, earlier people used to have code the behavior where they used to work with 1 dimension, 2 dimensions. Machine learning has led to people working with n dimensions of data and without just coding them or programming all the logics, all the rules, develop a great decision tree, and the tools will be developed and coded automatically. Deep learning is another subset which is trying to adapt from vast and vast amount of data. Again, the important word is vast amount of data. So if you feel like, okay, with small data, I should implement a deep learning, I would recommend not to do that. Couple of more terminologies which I have mentioned. One, strong AI or general purpose AI. So as you read, like AI is something which could help you to do things what human could do. Strong AI and general purpose AI is something which is believed to do the same, where it can do whatever human could do. One machine for everything. I see a person who are coming in this session and I'm able to say, okay, person A is like this, B is like this, and I'm able to personify all the different kind of discussions rather than just discussion around AI. Right now, we are still in stage of developing a strong AI. If we have to say anything which is close to, there has been like a couple of human robots which has been developed, or maybe a self-driving cars, which are strongly integrating a lot of AI to do a bigger problem. Most of the other business problems which you are trying to solve in Kaggle and everything, they all rely on a weak AI solution where what they are doing is they're trying to work on one single objective and they're trying to automate that narrow routine task. Again, we need to be focused on the word narrow and routine because the higher efficiencies or accuracies will be achieved when it's a repeatable task, because when a machine is trying to learn, they may not be able to learn of one-off case, but they say, okay, every time a person comes in, they are stepping in, they are pressing a button, and by pressing a button, the fan switches on. Once they start reading that, then they will learn and say, okay, switching on the button may lead to a fan being on. But if once a fan is on, once a tube light is on, anything like that, they may feel, okay, it's not routine, they may not find a pattern and they may not be able to learn. So something which is routine and narrow, which is very defined one case, they may be able to execute faster. So that was like quick of a background in AI and ML, so that when next time anyone comes and asks you, you are able to share with them that machine learning is a subset, number one. And secondly, if there's someone who comes and expect machine learning to do anything like a magic wand, it's not a magic wand. There is method to the madness. They are looking at automated narrow and routine tasks. So they need to have some pattern, and pattern will only come once it's routine. It is repeatable. That's number one. Secondly, what they are trying to learn is a VK where they are trying to solve one problem at a time rather than solving all the different problems at one time. Again, there are advancements which are made. Just like I mentioned, there are human robots which are getting created, self-learning cars which are getting created, but the commercial use has been limited to few players only. Now, if we start discussing the value which AI/ML generates, and the reason I want to touch base on the value is we are talking about business, and business needs to look everything from the terms of value. It is not like, okay, this is a great solution. This looks pretty awesome. And then the next question which comes, what should I do with it? You developed a great model of predicting a heart disease. What should I do with it? I cannot do anything. There is a model which is getting developed which predicts fracture coming up. What should I do with it? Can I do anything? There is a great forecasting engine which tells like tomorrow it will rain. Can I stop rain? No. Maybe I can plan according to it, but I cannot stop it. So there are some things where you need to define what actions could you take, what actions could you not take. There are something which are good to know, but there are something which are good to action. And when we are talking about businesses, business typically are not looking for just insights or a model. They are looking for an actionable model, actionable insight. When I talk to our data scientists, the great bunch of people who just like you come and work with me, and I say, okay, what are you doing? They say, hey, I'm creating a great algorithm which is able to classify my patients into their likelihood of a disease. I classify what actually they are likely to buy as a healthcare product. Sometimes they say, hey, I'm building a prediction model just like a language translation prediction, or maybe I'm trying to create what is the next thing which a person will do. People are trying to do forecasting to help with the workforce management. A lot of people are working with NLP and computer vision problems, and then they say, okay, I'm trying to do an unsupervised clustering to identify some patterns which are existing without my outcome window. And then there are people who are doing text summarization, everything. If you ask detail, okay, what are you doing within that? They will start talking about the methodologies, whether it's the unsupervised trade, deep learning, reinforcement learning, whether they are applying XGBoost, which works everywhere in classification today, and all those things. But If we open up and start talking about business only, and we ask, what are you expecting from AI ML? They say, my business runs on only two or three things. One is revenue, other is operations cost, third is sustainability. And when I talk about sustainability, I need to have the customer engagement, which is a new value stream, or something which could keep on creating a value, which sometimes is like supporting analytics. I will just share like what those supporting analytics means. Let us first touch higher revenue. If you're talking about businesses and how they are realizing value of analytics, most of them are trying to say, can I have more targeted member list to intervene, to attack? Sometimes people, you would have seen a great example of Netflix or Amazon's. They have a lot of sponsored things, but they have a lot of predictive models where they try to recommend you the thing which you're most likely to purchase, doing nothing but trying to increase the revenue. In the traditional world as well, what we are trying to do is when we are trying to sell a healthcare product or trying to upsell, cross-sell, we're trying to increase the revenue. So that's how the model, which is either a classification model or summarization model or unsupervised model will be. Second is operation efficiency, again, core of everything. Whether we are talking about fraud, waste, payment integrity, identifying where the wrong things are happening, or whether it is about automating a lot of things which are happening, or it may be as simple as trying to find a value out of a NLP based thing and what humans are doing, trying to assist them. Maybe when I go to doctor, when he needs to assess me as a person, I'm able to do that faster. The new value streams, when I'm talking or the sustainability, they comes through, say, chatbots, where right now, rather than putting up people, I'm able to provide 24 hours customer service. That's sort of the new value which AI ML has generated. The other new values which it has generated is the engagement, which is rather than you waiting for anyone to come up and attend you, there is someone who is always there. That's number one. Second thing, in terms of new value which AI/ML generates, is it helps you with new digital things like a smartwatch, a fall prediction, and all those things which can connect you to the right person, like an emergency when it is needed. Again, you will hear a lot of healthcare in examples in my conversation because most of my experience has been here. When I talk about supporting analytics, a lot of you would be working on some problem which may not be directly getting related to what businesses are solving, but somehow trying to support analytics. Now, a very simple example is I have a smartwatch which is continuously generating the data. What should I do with it? Okay, for the instantaneous data, it is good. But I need to understand trend because I can then consider some of the biomarkers, I can consider some of the alerts which may be useful for future detection, prediction, and all those things. So sometimes using that stream of data, I'm trying to analyze and just store those notifications, store those outliers, store those behaviors in a summarized manner because I cannot be storing the entire data which is generating on the real-time basis. So you're trying to do analytics, generate the data to support analytics. The other example is creating synthetic data. You may not have data of a lot of personals who are not still connected to internet or anything like that, who are not data savvy, and you still want to understand some of their behaviors and everything. You have some human intelligence and incorporating those human intelligence using your formulations of synthetic data, you could be able to generate those data to support more analytics to intervene them and to engage them. So these are the values which your business owners is trying to see. when you are doing classification or prediction, forecasting, clustering, segmentation, whatever it may be, great things which you are doing, they try to say, how does it marry to my revenue, operational efficiency? Is it something valuable to my customer? Is it something which is supporting analytics, which will help me do better in future? So now that I've talked about value to you, let me discuss a couple of scenarios and maybe we'll move ahead by discussing the scenarios more and more in detail. There was a stakeholder who once belonged to a marketing team. He was very excited about machine learning and AI. He came to me and said like, hey, can you create me a high precision, high sensitive model to predict which health product user will purchase? And my first reaction was, number one, do you understand? Like there is sometimes a trade-off between a precision and recall. Second, what will you do with the model? Are you trying to sell just one thing or are you trying to sell more things? Are you trying to just focus on one product or you are trying to do a product suite? What will you be doing with that? There was another person who came and asked a similar question. Can you build me a model to predict heart failure? And I was like, if you're trying to predict an acute condition, maybe you may not be able to manage it. What will you do if a person is having a heart attack? Could you give him a treatment upfront? Maybe not. But in case you're planning to select a patient for grafting, maybe it makes sense. Another scenario, an exciting analyst comes to me and says like, hey, I was looking at this data, which was on Kaggle, which was looking at a lot of chest x-rays. I built up a computer vision model which can predict COVID with XX% accuracy and everything. Can we deploy it? I was like, great. But do we know where the data came from? Do we know what is the value which we are trying to generate? Are you suggesting to use the model to navigate or try as a member? Are you trying to use it to replace RT-PCR? What exactly are you trying to do? How confident are you about the data which was deciding behind those Kaggle data? How much representative it is? How much confident are you about the flags which are available? Just imagine like a lot of people were not detected with, were not having a COVID positive report, but they were actually having COVID. So how are you catering to that? So a lot of people come and ask those questions where they want to use AI. Either they have created one and then they want, how do I generate a business value? Or there are people who will come and ask some of the questions, okay, do some analytics for me. There are other kind of people who come and say, hey, I want to solve a problem for obesity. Can you do a machine learning model and solve an obesity problem for me? So you will oftentimes see a lot of business people or analytics people coming up and talking different language. But in order to have a successful deployment, that's where connection between businesses and data becomes pretty important. You need to know how to marry the two, how to understand the business problems and connect it the data, understand the data limitations, solve it along with the businesses, so that when you are actually delivering the outcomes, it's not an uncertain outcome, but more a certain outcome. So when I talked about a stakeholder coming to me and asking a high precision, high sensitive model, the essential challenge which businesses seeing over there is an uncertain payoff. What if the model is having a low recall or a low precision? What if there are misouts and anything? The other challenge which we often face in business and which deters us for the successful deployment is human resource challenge. There are very few people who understand both the domain side and the technical side. And in the top management, even fewer people. There's communication challenges. You need to have people who are willing to adopt, invest, and take a bet on analytics. There are people you need to align to and make them understand the outcomes which will be generated and the way it will get deployed in the entire pipeline. Similarly, when we talk about challenges or cost of AI from the technical perspective, like I was talking about an example of people coming up with COVID model. we need to identify business opportunity, whether we are looking at triaging or replacing or supporting. We need to put up a team together. Why? People will say, hey, we all have a team. Why do we need to put a team together? Because putting up AI in application is not just about developing a model. It is about setting up the entire pipeline. It is about setting up the businesses. So it is about setting up those governance committees, which comes up and buys into the solution. Shankar, I see you being raised hand. Can we take questions at the end? You can just type in your question at the Q&A and we could take that. The other thing which we need to be concerned about the budgeting, not just budgeting of model development, but of deployment, maintenance, everything. One thing which sometimes a pure data scientist misses is the importance of data engineering. Training of the model is always important, and everyone knows how important it is, and everyone has been practicing that. Testing is something which becomes really, really, really important. Now, why it becomes important? When I begin the session, I talked about examples of Amazon hiring engine, Amazon hiring AI engines for selecting the resumes, everything, they go into Apple's engine, which was supporting and giving the loans, they went wrong. So not just testing among the data which we have, but testing in the data which we haven't seen is also important. Deployment and maintenance are two other components which we cover. So what we covered till now is, number one, what is the essential difference between AI and ML? Number two, what is the value getting generated from both the data science perspective and the business perspective? Three, the challenges which business faces in terms of AI ML and the cost of AI, which a technical person should be keeping. Now, how we'll take it forward is to understand that framework on step-by-step what we should be doing, while we have to look for a successful use case of an AI. So what I call a successful use of AI, it for me consists of 5 pillars. And I have given that framework a name, which is SALT-E, which is SALT, S-A-L-T, SALT-E. What does it mean is S, simply business, A, analytical objective, L, limitation, T, transparency, E is engineering. So AI is made to solve complex problems. But when we are solving complex problem, one thing which we miss is where at the end, we simply need to look at from the business perspective, which is either it has to attack your revenue, your operation cost, it has to be a new value stream, or it has to support your future sustainability from analytics perspective. You cannot be saying, okay, I built up a very good model which has complex model A, B, C, D. You have to just say how in the entire process it will be deployed, where it will be put in, and what matrices you will see changing. If I again start with an example of the COVID detection, which an analyst brought in. If I talk about the intervention, it could be, hey, are you trying to do an interventions where you are trying to look at it for a triaging, where a person who is not having access to RT-PCR, they go, they get their chest X-ray done, and that chest X-ray reports is used to triage and say whether he should get an RT-PCR or not an RT-PCR. That's one sort of intervention. The other could be he directly gets a treatment after X-ray has shown an RT-PCR done or not done. Again, I'm talking about computer vision. There may be others who may just try to create those models based on symptoms, and then they may look to start treatment. The problem which it will be solving is the operation efficiency, where the limitations of RT-PCR being available at scale, they would be able to overcome that challenge. If you don't have an RT-PCR problem and you're trying to direct toward X-ray, maybe it will be a challenge. Similarly, when I was talking about a stakeholder coming and asking me about, can you predict a health product which a person is trying to buy? I can say, Should I be looking at just one product or a recommendation engine? Should I be looking at product from the perspective of what he would buy, looking at that, or maybe I'm looking at the intervention where I say, hey, these are the three product mix which I may plan to sell, or it is the combination of product which I should be looking. So you need to understand what exactly the interventions is going to be. When I start talking about in healthcare perspective, again, solving obesity, am I trying to just fight obesity? Am I trying to reduce obesity? Am I trying to reduce other conditions which exist from the obesity, and how it would translate to business? So when you start with an analytics problem, don't start with the complex solution which you're trying to create. Start thinking, okay, the output would be whether it's a classification engine where you would be able to classify A or B, or it is going to cluster where you will generate some clusters or a summary. Who will use it? How will they use it? What changes will it lead to the business? And based on that changes, what the payoffs will look like. You don't have to think of the complexities which goes behind in making analytics model or the complex solution which are creating. Yes, surely analytics is made to solve those complex business problems. But in order to have a successful deployment, you need to understand about the business perspective which they are trying to solve. The second pillar which comes out is analytical objective definition, and along with it, defining the success measures. Oftentimes it happens where we say, let me try and build a model and let's see what will come out of our model. I sometimes don't buy on those thoughts. For me, you need to start with the predefined success measures, and that comes with an intervention. Say, I want to intervene on for a COVID detection. I need to be sure whether I need a high precision model or a high recall model. If I'm looking for a treatment which could lead to lots of adverse effects, maybe some sort of side effects or anything, maybe I would say I need a high precision model. If there is a low cost treatment which goes with the COVID, where everyone is given paracetamol, everything, I would say even a wrong detection may not be such a big problem. So let us go with a high recall model, then a high precision model. So you need to define those success measures. Secondly, even when you are trying to do a prediction model or a classification model, you need to be sure of how that analytical objective will look like. Are you trying to predict the sales at that moment? Are you trying to predict or sponsor a product which is likely to purchase in, say, next 10 days? Say, you know, a Diwali offer you are going to roll. So are you trying to see, okay, how likely is a person to purchase a particular laptop in, say, next 30 days? That's one sort of model. Other is, hey, based on his recent search, everything, I know he's trying to purchase a laptop. Let me try to show him laptop everywhere and trying to sell the laptop. So you need to be clear about analytical objective, whether you're trying to predict for that event that time, or maybe an event which can happen in next 30 days, 40 days, how your analytical objective will look like. In healthcare, when I was talking about problem of obesity, we started with the problem where we said there are a couple of things which we want to do. Number one, we want to look at not obesity as such, but the other conditions which are related to obesity, because those are costly. Obesity is not, but the other condition which it causes, they are costly. Secondly, we said like, we want to look at a 2 years time frame. So we may not be looking at a longer time frame, but just a 2 years time frame, assess whether our intervention is successful or not. So you say, okay, obesity generates 10 years condition or 20 years condition. Our objective is to limit it to 2 years, and not just about obesity prediction, but about the other condition which it could cause. So a couple of things over here. Number one, translate your objectives pretty nicely, your business objective to analytics objective. Second, define those success measures pretty strongly. Third, when you're talking with business, you need to talk about the limitations. A lot of time we just sell about analytics, what the great thing it is, what it will do. Sometimes what we don't discuss, what it won't be able to do. When you're trying to do a prediction model, maybe sometimes lack of transparency, maybe sometimes because it's based on correlation rather than causations. There are a lot of things which may go wrong. There are factors which sometimes you take, like you look at a sales model and you're trying to put in the demographics and everything. Demographics sometimes doesn't, it's not controllable. So even if you want to change it, you cannot change it. So that's an uncontrollable thing. And it is still becoming a very important. So stakeholder want to understand what are controllables, non-controllables and everything. So you need to define those limitations from the analytical objective, which your business will find challenging. Again, when I said about obesity, there was like, okay, I'm focused on next 2 years. Essentially, long-term impact may be subsided. If I'm looking at just 2 years horizon, maybe those are the old age people which may have a higher things in 2 age period. Younger people could still live with obesity for a longer period of time. When I start talking about your sales decisions, typically some of the limitations you will be having. Hey, did my recommendation influence that sale decision, or was he already likely to purchase that decision? I may not be able to sometimes relate it to the real search which he is trying to make. Say, I know he's trying to buy a laptop and I start publishing laptop everywhere, but that particular visit which he's coming in, maybe at that time he is trying to look look at a charger, and he started with the laptop search because he essentially was trying to look what charger a particular laptop has, and he wants to go to toward a charger. So those are some of the small things which gets missed out. The other big limitations which we sometimes don't talk about is some of the protected group or the underrepresented sections. They get impacted because of model. Model is generally working with a loss function. All of you are data scientists who would have heard about modeling, how the loss function works, everything. It is doing nothing, but it is trying to minimize the losses. And in order to minimize the losses, they generally focus on the large values. So those minority groups may get impacted, just like I mentioned about example of Amazon and Apple. So you need to mention about what a model can do, cannot do, because that will define, okay, for this minority, should I be having a different model? Should I be excluding that factor? Should I be testing those models? Unless you state that out, you may face an ethical dilemma at the end of it. Fourth pillar is the transparency, because oftentimes when people come to me and say, hey, I built a great model, I say, okay, why do you think this was the prediction value? And they say, oh, I don't know, model did it. I don't know. Maybe we need to do a thorough analysis of that. What model has learned, why it has learned. Do we have examples of around that? Do we know the feature importance? Do we know the sharp values? Do we know the controllables, non-controllables? Can I club it? Because that will help you break those awkward silence. And unless your business owners understand that, they won't be able to take a call whether they deploy or not deploy. So you have to marry it with something which a person sitting in front is able to assess. And if you cannot, maybe you will be able to make the person sitting in front measure that as well. Fifth, you need to engineer. You need to understand the entire pipeline and how it will be built. I have seen cases where people have used the data elements and feature, which most of the times are not available to them at a real-time basis. Say I talk about an adjudicated claim. Maybe adjudicated claim would come after the adjudication had done, which may take like a month, 2 months, or maybe 10 days. I cannot use that for a real-time prediction. So I'm trying to predict clinical conditions based on my claims information or adjudicated claims, which is 10 days delay. Maybe that's a bad model. I've seen people who have built up a model for a condition, and as a feature engineering, they took a feature of the prescription which he was taking. Maybe they are just missing on the sequence of events which may be happening. So you need to understand how the deployment will happen, the data which will be available, which will not be available from the feasibility perspective. Otherwise, your great models may never see end of the tunnel. And this is why I call is a SOLVE principle, because as we look at, you talk to business, you work with them with the analytical objective, you talk to them about limitations, you are solving a lot of AI challenges in businesses, which is about their communication, their lack of knowledge, which is about the uncertainty. You talk about transparency, you talk about engineering, and you're solving for AI in application where a lot of deployments are yet to come in. Again, one last thing, this framework is great, but in order to follow as a person, you need to have a practitioner mindset. And in order to have a practitioner mindset, which is foundation for an application, you yourself need to understand those key terms. You need to understand difference between whether it's a hype or a reality. A lot of people go by, okay, a cloud computing has come in, quantum computing has come in, computer vision has come in, I need to apply this. You need to understand what is an R&D shop versus a value creation shop. You need to understand the difference. You need to understand what is in the stage of hype, what is the reality. So you need to be able to distinguish that. You need to be able to make a perspective of what AI could do and what it cannot do. You cannot say AI and ML could solve everything. There are rules engine which could work much better than AI ML in some cases. Just like I said, switch the button on and the fan switches on. Your AI ML may still have an error. Your rules engine may not have an error. So a rule engine could do much better. If it is one-off cases, your AI ML won't be able to pick it up. If it is an underrepresentative case, and if you're trying to solve for the whole population, maybe that underrepresented population may get impacted. So you need to make more sense of that. You need to communicate with senior leadership specialist peers, because they are going to be the users, they are going to be given the feedback, they are going to be able to assess the ROIs of it, and you'll be able to talk about it. You need to know what the building blocks. You don't need to be focusing on training the model, you need to talk about the entire pipeline. You need to learn about the technologies, and at the end, you need to have foresight of the future, because a lot of your machine learning models will assume environment to be constant, which definitely is not the case. The models which are built pre-COVID, during COVID, they were not working. Now, maybe working slightly. So you need to understand that pretty nicely. So with that, what I would leave, in order to have successful implementation, don't complicate things. Just think business, align your analytics to the business, be transparent about your limitations, about the outcomes, and engineer it. More often than not, you will be able to have success. I'm opening up for questions now. I know there's one question. So there is Shankar Sahu who is asking, can you tell most important deep learning algorithms? So Shankar, when we are looking at the algorithms, one thing which we need to understand is there is not one algorithm which is meant to solve everything. Nowadays, if we talk about, say, XGBoost, people will say, hey, XGBoost will be able to run in most of the cases. Maybe in Kaggle's of the world, XGBoost is the one which solves most or almost every problem which they come with hypertuning or something like that. What we need to understand is the problem which we are trying to solve and how we are formulating that problem. If the data is not sufficient, deep learning is meant to work with the huge use data, number one. Secondly, it is an n-level deep data, so everywhere there would be some computing which will happen. So you need to have a lot of processing power. Other element which you need to consider is sometimes your data may not be representative. So it is not just about the algorithm, but understanding the limitations of the algorithm and the applicability of the algorithm, which we need to assess. I repeat, Akimu, is any problem CNB solved by machine learning? Can you expand on that? Maybe I cannot understand the question. Akimu, can you expand on that? Any other questions? So I will just try to answer, Akimu, what I'm understanding. Basically, you are checking like machine learning problems which could be solved by customer experience and all those things. So let me tell some of the good use cases which have been deployed. A lot of people are using a lot of videos and photo links nowadays to review anything. You would have seen a lot of reviews which are coming of any product which you buy. Those computer vision problems sometimes try to look at the appropriateness on appropriateness. They try to flag all those things. They sometimes try to look at through the images how it could be classified so that it could give a person perspective or review. Those images has been used a lot in self-driving car where they are trying to formulate those conditions to train that. Similarly, in terms of feedbacks and customer experiences, a lot of those text notes reviews has been come up where they have tried to classify, they have tried to extract words to generate like topics and things which it may be related to identify what are the good people have said, what are the bad people have said, and everything. The other big examples is the continuous engagement which you drive with customer. Machine learning is playing a huge role. Humans work with behavioral science psychology, and you need to be interacting with that, continuously take feedback and keep on offering new things. Sometimes as a human, we may be able to process, say, 2 dimensions, 3 dimensions, okay, where the person is and everything. They may not know about the other conditions the person is having, the other purchases which he has been having, and everything like that. So those are things where a lot of computer visions are coming in, and everything is trying to work for lots of lot of customer engagement. When you talk about computer vision to solve physical location for product recommendation, definitely like in US there are Amazon stores and everything which are trying to solve some of those problems where there is unmarred stores where you just pick up the items or put it back. There are cameras which are installed there which will be able to know what is there in your cart. So a lot of computer vision has been installed on that. Again, lots of computer vision sometimes try to look at your environment, try to do a best recommendation as well. You would see Google Lens where once you are opening up your Google Lens and trying to identify, okay, what's it, they will try to identify the place, your location, and they will give you a nearby recommendation pretty easily. So if you want to go and have a food, if you need to go and have some gas or petrol, they could guide you to those places very easily. Sometimes when people say, okay, identify this object, Google Lenses try to solve it. If they don't know it, you just open up a Google Lens, they would be able to identify it, what it is. Again, lots of training goes in that, a lot of biases goes in that. One of the Google example which you could see is you can just try to give them a data of the kind of shoes which you wear. We'll see sometimes people are not drawing the heels and everything, which are also a type of shoes. So you need to be more explicit in giving those data for training. But once they are trained and trained nicely, they are solving a problem in terms of making recommendations regarding your location, looking at where you are, and even sometimes understanding from your surroundings whether you need a help or not. Amazon's or Apple Watches are also trying to do that, where they try to look at your location, they try to look at your environment, and if you need help, they are automatically connecting you with 911s. Any other question? Okay, then we are at top of an hour.